How Sex Drives Evolution. My name is Josafath Aparicio, and my partner,
Zahida Ahmadi.
To begin with, the male peacock is brightly colored, as seen on the right and above, has very large plumage, and is very easily seen by predators. These adaptations decrease the survivability of the peacock, and yet, why do these traits remain in the gene pool? Reproduction versus survivability. Males throughout the world are seen to have traits that decrease their survivability. Jerry Husak at Oklahoma State University conducted an experiment using collared lizards, as seen on the picture above, to test if the brightly colored males were targeted more by predators. They used clay models with the male versions being brightly colored and females being a dull color. Within the first week, 35 out of the 40 males had bite marks, while no female models had any marks whatsoever.
To continue with reproduction versus survivability, we can start with sexual dimorphism, which are traits that differ between males and females. Examples are colors and size. Many traits found on males decrease survivability and were seen as pointless. Charles Darwin was the first to recognize a pattern. The purpose of these traits was not for survivability, but rather reproductive success. Recognize the trade-off between survivability and reproductive success. Sexual selection. Sexual selection is a type of natural selection that increases an organism's ability to find a mate. Term coined by Charles Darwin. There are two types of sexual selection: direct competition and female choosiness. Direct competition is where males compete with other males for ability to mate with females. Female choosiness is females who choose which male they want to mate with, an indirect form of male competition. Direct competition. Males actively compete with one another to mate with females. Traits under this selection favor large body size, stronger weapons, or anything that helps the male to win a contest. For example, the large manes on the lions seen on the bottom. They're clearly fighting against one another to compete for a female. And the second picture is of a ram who has horns that are larger than some of the other males, which make it more competitive and can win a fight or a contest better.
Continuing on with direct competition, northern elephant seals grow up to 20 feet long and 6,000 pounds. Females, on the other hand, only grow to 10 feet and weigh only 1,500 pounds. You can see a clear difference in the sexual dimorphism between males and females, as the males are much larger than the females. Males have more than one mate and guard many females. When competition occurs, the males will have a physical brawl, as seen in the picture above, with the winner being able to mate with the females. Only 10% of the males produce offspring over several mating seasons. This shows that only the biggest and strongest males will be able to create offspring in future generations. Another form of sexual selection is female choosiness. The females actively choose which males they choose to mate with. This type of selection favors adaptations such as bright colors, ornaments, songs, and mating displays. This is a form of indirect competition. Males compete with each other for the attention of females, but do not actually, quote-unquote, fight with each other. Biologist Alfred Russel Wallace created an experiment using peacocks to determine if their plumage was the reason for reproductive success. Marion Petrie and Tim Halliday in England used Wallace's experiment. What they did is they cut off 20 eye spots off a group of peacock males, and they left a control group of males to see if there was a noticeable difference. On average, the ornamented groups of males had 2.5 fewer matings than the control group. So this shows that females wanted to mate with males that had the most eye spots.
So then why have sex? Asexual reproduction allows for organisms to reproduce more. Selection favors those who can reproduce the most, so why isn't asexual reproduction more common? One theory suggests it speeds up evolution. The random shuffling of genes occur during sexual reproduction. It can create new traits and can purge unwanted ones as well. Sexual reproduction. Why are there two sexes? Why do the two sexes have different sizes and amounts of gametes? It is unknown why these traits occur, but there are many theories. I already went over that we have two sexes, and now we'll go over why they're two different sizes. One possible reason is that having two sexes is the simplest and most stable way to have sexual reproduction. Having different amounts and sizes of gametes causes organisms to have different mating strategies. Males and females will have different methods to find a mate and having offspring.
There's a difference between male gametic size and production compared to females. Males are able to create many gametes and can potentially father many offspring. What they are limited by is the number of females they can actually reproduce with. Females, on the other hand, have limited amounts of gametes and must choose who they mate with. They must expend a lot of time and energy to raise the offspring, while males do not. Males risk much less than the female risk. As with this, there is much variance in the reproductive success of males than there is with females due to these reasons. In most species, it is the female that cares for the offspring. However, in some rare cases, it is the male that rears the children and the female does not. Animals like seahorses, pythons, and phalaropes take care of the offspring. Males will only carry one brood at a time, and the gestation period lasts longer than females. Males will invest more time and energy in rearing the offspring in this case. Females must compete for the non-pregnant males compared to, in these animals, the roles are reversed as females have the bright colors and ornaments while the males are relatively drab.
So then why in most cases do females choose the males? Darwin's hypothesis on why females choose males stated that a male's calls, colors, and ornaments evolved via female choice. He said that females chose the males based on pure aesthetics. Why else would females choose these males unless they find them appealing? Female preferences are adapted. Preferences have evolved through selection to favor certain types of traits. Females would benefit in two ways, directly and indirectly. Direct benefits. A female would benefit by picking a male who will help her produce more or healthier young during the act of childcare. Features on males such as bright colors signal to a female that the males have large or better benefits. Features on males such as bright colors.
An example of these direct benefits was found by Geoff Hill at the University of Michigan, who studied house finches and wanted to see if bright colors on males have some sort of benefit for the female. These brighter colored males, on average, receive more mates than the dull colored ones. The red color on their house finches is supplied by pigments in the food they eat. Males with brighter colors, on average, were better at obtaining food, thus can feed their offspring much easier. This proves that the bright colors in males signal to females that they will obtain a benefit from the males. As you can see in both these pictures, the males have bright red coverings along the front of their body. The red pigment signals to the female that is better at collecting food, thus better able to feed its young while they are being raised.
Now moving on to indirect benefits. Mates with indirect benefits show females that their genes are better than their competitor. There are three types of genes that will increase in frequency together. The first one is genes for a male indicator. They reflect that he has good genes. Second is genes that make females prefer that indicator trait. And the third, the good genes whose presence is reflected by the indicator.
We assume that female choosiness arose due to females receiving a direct or indirect benefit from their mates. However, there's a simpler but other form known as a sensory bias model. This model assumes that the evolution of sexual dimorphism is driven by pre-existing biases in a female's nervous system. These biases can come from a byproduct of some other function besides finding a mate, such as finding food. For example, if we are members of a species with a visual preference for the color red, since this preference helps them locate ripe berries and fruits. If a mutant male appears with this color, he might be preferred by females simply because of this pre-existing preference. The males would have an advantage over other males that do not have this color, and this color dimorphism would evolve due to this. The sensory bias model suggests that females would not obtain any direct or indirect benefit from choosing a particular male.
In total, this is how sex drives evolution.